Alright, so I'm going to break this up into a couple of different videos. We're going to start off, this is the gas laws foldable that we started in class. We're going to start off, if you weren't with us or just didn't get this part, we're going to start off the foldable for Boyle's law. So here's all the information that you'll need to have for Boyle's law. We'll start off with, first of all, Boyle's law has to deal with pressure. So we abbreviate pressure with a P. And volume V. And keep in mind you're looking for units for pressure and for volume. So you're looking for things like, for pressure, you're looking for millimeters of mercury. You're looking for, or like ATMs. Those are the two big pressure units we'll use. Volume, you're looking for things in liters. Okay. So that's some things you want to put probably in your foldable under Boyle's law. The other thing you probably want to put in your foldable for Boyle's law is the actual formula. Boyle's law is P1V1 equals P2V2. So the pressure of the first times the pressure, or the volume of the first, equals the pressure of the second times the volume of the second. Basically saying, okay, if we start with a particular pressure and volume, that if we change it, it's going to be a ratio of the new pressure and volume. These two are an inverse relationship. Which means that basically what that means is that if you have, so like if the volume were to go down, the pressure would go up. They're opposites. Okay. So maybe let's look at a problem here to work through. So you might want to write this problem in your on your foldable so you have an example. So I'm going to bring this over here. It's from PowerPoint. So you can see, maybe see the whole problem here. And I'll use the paper underneath to actually work out the problem. So we're going to do this top one here. It says a gas occupies 12.3 liters at a pressure of 4 millimeters of mercury. What is the volume when the pressure is increased to 60 millimeters of mercury? Okay, so, oh, bright light. So we're going to start out with our equation. Ooh, why is that light so bright? Shine on, there we go. So we're going to start with our equation over here. So we have, I just moved that light all together. There we go. There we go, I'll just turn it off. That's my hand. Do you see my hand? Alright, so we're going to start with the equation. P1V1 equals P2V2. Okay, so there's your equation. Now, our goal is, we have technically four variables. P1, V1, P2, V2. Okay? Now, those are our four variables. Now, if we know anything about algebra, we've got to find at least three of those to solve for the last one. So, if I look at my question here, again, the key is start looking for numbers as you go through. So, a gas occupies, we'll look at that, 12.3 liters. And as we stated earlier in our, to put on our foldable, liters is a volume. So, this is the first number we come to, and it's a volume. So, what I'm going to do is I'm going to come over here, and under volume, I'm going to put 12.3 liters. So there's my first volume. Okay, if I go back to my problem, and I keep reading, 12.3 liters at a pressure of, look at that, another number, 40 millimeters of mercury. So remember again, as we put on our foldable, 40 millimeters of mercury. Millimeters of mercury is a pressure. So I'm going to go back over here. It's my first pressure, in fact. So I'm going to put 40 millimeters of mercury right here. So I have my first pressure. I have my first volume. So next, I'm going to go back, look at my question one more time. Okay, so I keep reading through, and then you'll notice that the next number you have is this 60 here. 60 millimeters of mercury. So we have 60 millimeters of mercury. So millimeters of mercury again is a pressure. We'll already have the first pressure. So I'm going to go and I'm going to fill in the second pressure. So 60 millimeters of mercury. Okay. And those are the three that I have. So the volume is going to be a question mark, meaning that I'm going to find it. Now notice though, however, that your volume here is in liters. So your volume here that we're going to find is also going to be in liters. Because notice the pressures, their units match. So our volume units are going to match. Now, so we're going to use our equation. So we're going to take the first pressure, which is 40. We're going to multiply that by our first volume, which is 12.3. Then you're going to set that equal to your first pressure, which is 60. And then we don't know what that V2 is, so I'm just going to call it V2. You could call it X. You could call it, all kinds of things. But I'm just going to call it V2. Now, we start doing the math, right? So we have to clean up our problem. That 40 and that 12.3, we're going to multiply together. So I'm going to grab my calculator here. 40 times 12.3. And calculator says 492. So I'm going to come on over here. 492. That equals to 60 V2. Now, should look like a basic algebra problem, right? All you're going to do is divide each side by 60. 60. So V2 is equal to 492 divided by 60. So again, if I come over here to my handy dandy calculator, ooh, that's bright, and I go 492, you can't see that at all, so I don't know why I'm showing you, and I divide that by 60, is 8.2. Now remember, you have to label that. So it's a volume, and we said earlier that our volume is going to be liters, so you got to make sure you put 8.2 liters. And there you go. That's Boyle's law.